All right, I'm just going to say this again so that it's on the recording. What I did is I divided up questions 1, 2, 3, and 4 to everybody. I'm just going to go around from group to group and we're going to write out the derivatives. So what I need for you to do is write out the ones that weren't the ones you did so that you have all of them. You don't have to write out all the work. We're just going to put the answers. Okay. So group 1, what did you get for your derivative? I agree. Good job. Everybody write that one down for number 1. You don't have to do all the work. We did divide and conquer. Group 2, which was both of you, I put you guys together since you both only had 2 people. What did you guys get? Was there agreement there? Perfect. All right, I love it. 2x plus 5. Group 3, that was you guys in the back. What did you get? That's really, really close. 4x. Mine too. Okay, there we go. I agree. And then group 4, what did you get? 8x plus 5 is right. What I'm going to do is pause the recording real quick so we can talk and then I'll start it back up again. Okay, so let's look at them. The first one. What did you do to get from here to here without doing any work? You multiply the x. Multiply is the good word we want to use for that. Multiply the exponent down. So it's 3x and then... Do you remember when we graphed derivatives? And do you remember the envelope activity when you matched them? Every time you do a derivative, it goes down a degree. That's where the subtracting 1 comes from. So when we look at this one, we brought the 2 down. We multiplied the 2 down. It dropped to a 1. And then what happened here? Because this is really a 1, right? So if you bring that down, 1 times 5 is 5. It drops to x to the 0, which you just don't write. That's nothing. And then this one here, 2 times 2 is 4, drops from a 2 to a 1, and then minus 3. What happened to this? There's no x. It's what we call a constant. That's a horizontal line. What is the slope of a horizontal line? And remember that a derivative means slope. Okay, so the constants are going to go away. And then this one, 2 times 4 is 8, and then plus 5. So what we're going to do is we're going to go to our little sheet of rules. Now, it doesn't matter which bubble you write it in, as long as you don't use, bless you, the really huge one. That's for the trig stuff. And the reason it's so huge is how many trig functions are there? 6, and you need more space to write all of those ones. Okay, so you can pick any bubble you like. I'm going to do this first one. This is what's called the power rule. And so we're going to put all our rules on this sheet. So d dx, that is instructions that mean take a derivative. When you see d dx, that's like it's saying take a derivative. That's your instructions of x to the nth power. So it could be x to the 5th, x to the 7th, x to the 22nd, you know, whatever it is. You bring the n down, you multiply the power down, and then it's x to the n minus 1. You subtract 1. The reason why you still have to learn it the other way is, I can't explain it until we get to the end of this unit, but I have a whole worksheet that goes through a ton of examples of how that pattern, that I just erased, why did I do that? The thing that was right here shows up on the AP exam. You still have to know it. Also, do you remember on the free response when you had to prove something was differentiable, limits from the left, limits from the right? You still had to know it. It wasn't a waste of time, okay? So you can stop hating my guts right now, all right? So we're going to go back to the examples sheet and do the first couple of examples. So for number 5, and again, it's a little dry and boring. Your directions are find the derivative. That's what all these are. Find the derivative, find the derivative. That is unit 3. You're going to memorize all the derivative rules and then use them, okay? So term by term, just look at the first term. Multiply the 4 down. What are you going to get? So it'll be 12x to the 3rd minus, then what? 12x, and that's it. Now, how far do you have to go? I would say use common sense. If it seems simple enough to factor it or do some algebra, then please do that because those are skills you need. If it seems outrageously complicated, then you can feel free to leave this alone. I think this one looks reasonable to do some factoring. Do you get what I'm saying? Common sense, it's not too terrible. What can you factor out of both terms? Now, I'm going to verbally take you through this. When you factor out a 12x, what do you get left with? X squared minus 1. How does that split? X squared minus 1. Good. X plus 1, X minus 1. So again, use your common sense. If it seems reasonable to keep going, please do it. If it looks like an utter disaster, then go ahead and stop. All right. But algebra skills are something that you do need, so we should, use those. All right. Before we actually do this problem, I'm going to rewrite the equation. Does anyone remember what's the exponent when you have a square root? 1/2. Okay, so this is going to be fun with fractions, guys. But if you have to deal with a fraction, isn't 1/2 the fraction you would pick? It's not going to be that bad. You're going to be okay. All right, so f prime equals, you're going to multiply the 1/2 down and then put x, and you're going to subtract 1. So what is 1/2 minus 1? Negative 1/2. Good. Now you have to fix the negative exponent. So here's what I suggest. Draw a fraction bar. It's like your line in the sand, and you're going to decide who goes where. Now we have a 1/2 out front, so that's going to just stay a 1/2. X goes down to the denominator. Why? Because it's negative. The negative is what moves it. The negative is like switch sides. So X is going to go down here, but it will be a square root. And why is that? Because of the 1/2. Now, here's my suggestion for this. You're going to do derivative of square root a bunch. You are not going to want to deal with 1/2 and negative 1/2 every time you do it. So I understand that this is already going to be a lot to memorize. And I understand that when you leave here, you have a lot of other stuff to memorize. I 100% get that. But my suggestion is you would do well to just memorize derivative of square root is 1/2 square root. I just promise it will save you a lot of hassle in the long run. In fact, maybe on your rules sheet, let's just put that one on the back. Derivative of square root is 1/2 square root. It will just help you and save you a lot of headache later on if you just know that one.
Do we have to put the square root at the top?
No, the square root will go in the denominator because it ended up negative.
Do we have to rationalize?
Oh, no, we don't do that in calculus. Sorry. No, we just don't do that. We just don't do that. Okay. Sorry. I'm so used to leaving everything alone. I didn't even understand y'all's question. No, we don't do that. Leave it alone. Okay. I know, right? Well, so the reason we did all that rationalizing is so that on the unit circle, it was square root of 3/2 and all that stuff. So that's why we did all of that. Yeah, so that was the purpose behind that. All right, I'm going to also rewrite this one before we do the problem. It's 3x to the what? Because it's in the denominator instead of a 5. Good, it's a -5. Then we're going to do the problem. So a lot of times it's helpful to rewrite the equation before you do the problem. Now just do the power rule. You're going to multiply the -5 down. What would that give you? -15. Put x. Now it's a little tricky. You have to subtract 1, so it's going to become more negative, -6. Perfect. And then we're going to fix it. You can't keep the negative exponent. So I always just draw a fraction bar. -15 goes on the top. And if you're like, why was that? It's really -15/1. If you want to stick a 1 in there, you can. But then what goes on the bottom? X to the 6. Okay, it's negative, so it goes back down to the denominator. And then I threw a easy one here, but it's new to you. So what do you think is the derivative of just 16/23? Why is it 0? So oh, I love that you even said slope. Slope is 0. It's a constant. Okay. I am going to go over, we're going to do 3 rules today because power rule is such a simple one. I'm going to do the next rule and then we'll do our 3-minute break. Okay. So the next one we're going to do, and I don't have like a reason why for this. I'm just going to tell it to you. So again, you can use whatever bubble you want, but don't use the large one. I'm just going to use the next one down. Your next one is product rule. What does the word product mean? Multiplication. All right, product means multiplication. So d dx, that is instructions that mean take a derivative with respect to x, is what that means. And we're going to have one function times another function. So it's f times g. Do not get hung up on the f and the g, because it could be q and r or l and m. Do you know what I'm saying? They can change the letters of them. It's just an arbitrary letter of the alphabet. In your mind, I want you to call them the first one and the second one. Are you with me? Because the letter doesn't matter. It's the first one and the second one. All right, so this derivative is the first one times derivative of the second one plus the second one times derivative of the first one. And I don't do a proof of that. If you want, bless you, the reason why, you're welcome to Google product rule proof and enjoy yourself. Or not, you know, whatever it floats your boat. Now, because it's a plus sign, does it really matter what order you put these in? No. And looking just at this part, could I even write these the other way around? Yeah, that's fine too. So this is very forgiving. Okay. First times derivative of the second plus second times derivative of the first. Now let's go back and do some examples on it. So looking at number 9, as a heads up, this is going to be about this long. It's going to encroach on the space for number 10. All right. So you're going to start all the way over here and it's going to go the whole way across. We'll do number 10 below that. Okay. So f prime equals, and it is, well, let me back up a second. The hard part is identifying which rule you need. Can you look at this one and think why product rule is the correct rule? There's 2 separate items. Do you get what I'm saying? This is the first one, and then this is the second one. Okay. So it's going to start with the first one. So just copy that down. Hey, Ms. Cole, looks like you just copied it. Sure did. All right. So the first one times derivative of the second one. So I'm going to cover all this up. We're going to just look at this. And we're going to use the power rule. All right. So you're going to bring the -2 down. Now be careful, because when you subtract 1, it's going to be more negative. So what's your power now? -3. Good. Plus, you just do term by term. You do 1 plus 5. Good. So to recap, we did the first thing, derivative of the second, and then it's going to be plus the second thing. So just copy that down. Don't do a copy error. Times derivative of the first. So I'm going to cover all this up. Just look at the first thing. What would that derivative be? 3x squared plus 7. Good. That does not look fun, so we're going to leave it. Let me say one other thing. And do you see how there's a negative exponent in the problem? That means we can leave a negative exponent in the answer. You follow what the problem did. So if they had the negative exponent, it's okay for you to leave it because we're just following what the problem said. So the rule of thumb is you present your answer in the same way the problem was given. So if they used a fraction exponent, you can leave it as a fraction exponent. But if they didn't, then you have to fix it. Okay. Isn't that how significant figures work? Like however many the problem used is what you have to use. Same idea as that. Okay. So that was number 9. We're going to do number 10 below that, since it's like common sense is telling me that's a disaster and I'm not touching it. Okay. As a heads up, this next one, we'll do some distributing and combining like terms. This one will be okay. You'll see the difference. Okay. So first of all, do you see how it would be product rule? Like you have 2 items, 2 totally separate functions. All right. So f prime equals, what am I going to put first? Thank you. The first thing, 2x to the 7th plus 4 times derivative of the second thing, which would be 2x minus 3, good, plus the second function times derivative of the first, 14x to the 6th. Good. Now, this won't be fun, but you can multiply these together and it's just going to be a bunch of distributing. And again, I don't want you to lose your algebra skills. So it's not going to be fun, but it won't be that bad. You'll be okay. All right. So let's multiply these. The first 2 times 2, 4, x to the 7th times another x, the x to the 8th. Now I'm going to draw in my little rainbows. I like to do that. When you distribute to here, that'll be minus 6 x to the 7th. When I multiply the insides, that'll be plus 8x. And then, oh, good. Why is it minus 12? Yeah, you're like these two. 4 times negative 3. Good. All right, then you're going to distribute this 14x to the 6th through there. That'll give you 14x to the 7th minus, oh gosh, what's 14 times 3? What is that, 52? Oh, 8th, I'm sorry. 6 plus 2 is 8. Also, did I do that right in my head? No, that's 42. Minus 42 x to the 7th plus 14x to the 6th. And then we're just going to see if there are like terms, which there are. So what's going to go together? All right, x to the 8th, that would give us, what is that, 18x to the 8th minus 48x to the 7th. And then I don't think any of the rest of that goes together, but I'm going to put it in descending order just because of my OCD. And then that's your answer. Again, I don't want to always skip the algebra just because it's not fun. I would love to. I would love to be like, yeah, we're not doing that. But then you'll lose your skills. So, you know, we should do that every once in a while. Okay. Yeah, but if it is multiple choice and you take this derivative and you don't see that as one of your choices, you have to continue working until you can pick A, B, C, or D. So that's why I don't like to skip it every time, because then you'll, you know, lose your skills. No, please do nothing. Okay. Start all the way over to the side. Do you see how we would need a product rule? Okay. So it is the first thing. And then we're going to do derivative of the second. Now I'm just going to write this off to the side in the margin. 4th root of x. That means x to the 1/4. So when we do that derivative, you will bring the 1/4 down, put x, and you have to subtract 1. So 1/4 minus 1 is negative 3/4. Good. Anything else to that one?
We're gonna have to factor in.
Well, yeah, I'm going to get to that, but is there any more to that derivative? Why not? Constant. Good. Okay. Plus, then you're going to put the second thing and then times derivative of the first. What would that be? Yep, 3x squared plus 2. Now, the only thing I'm going to do is fix this, and I'm going to use my eraser and just erase it and fix it so I don't have to write the whole problem over again. Does that make sense? You can write it all over again if you want to, but I'm going to draw a fraction bar. We had a 1/4, so that part stays. Where does x go? Y on the bottom, because it was negative, and it was x to the 3/4. That's going to be a 4th root of x to the 3rd. I just ran out of space, so I'm going to just write that prettier. So it's a 4th root of x to the 3rd. If there is, now listen, because I know everybody's like, I don't remember this from algebra 2. If it is a 4th root in the problem, it's going to be a 4th root in the answer. The type of root can't change. Do you understand what I'm saying? So like if that's a 4th root in the problem, you need to have a 4th root in your answer. All right, so we're going to go back to our rule sheet and do one more rule for today. So we just did the product rule. That's for multiplication. What word means division? Quotient. Okay, so this is called the quotient rule. And believe it or not, that's for when you divide two functions. So d dx is instructions that means take a derivative, and it's going to be for one function divided by another function. Same pep talk. Do not get hung up over f and g. They could be M and N, you know, they can change the letters of them, so don't get hung up on that. For this one, I want you to call them the numerator and the denominator in your mind. So for product rule, it's the first one and the second one. Here it's the numerator and the denominator. This one's gonna look like a lot. It's not actually that bad. It goes well every year. The first part of it looks very similar to this, but there's gonna be subtraction instead of addition. So you know how I brought up, it doesn't matter what order you get this in. If you mix it up, it's no big deal. You can't mix up subtraction, so you do have to start in the correct place. If you remember where it starts, you will likely get the rest of it. So try to remember it starts with the denominator. So you start with the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And there's one other thing, but I'm going to stop there real quick. Do you see how that looks a lot like the product rule? Just remember where, and don't get hung up on F and G. Okay, it's where you start. So it's that, just minus instead of plus. And then it's over the denominator squared. Now, here's the most common mistake that happens with these. Do you see how there's a g of x here and a g of x here? Because people see the same thing written twice, they will cross it out. No cancellation without factorization. If you were with me in pre-calc, you heard that. Don't cancel if you can't factor. Basically, just don't cancel. Okay? Let's try a few of these. So go back to your problem sheet. We're on number 12. You're going to have to kind of come down here unless you wrote really tiny. And again, we're going to use common sense. If it seems reasonable to keep going, then we will. If not, then we'll stop. This first one will be all right, though. We'll be able to keep going with this one. So remember where you start. It starts with the denominator. So just copy that over. And I know you're writing this down, but can you just get your head up, please? All right, so the denominator, and then it's times the derivative of the numerator. What would that be? Just 3. Good. Isn't that nice? Because it's linear, and 3 is the slope. All right, minus the numerator, and then times derivative of the denominator, which would just be 2, good, over the denominator squared. Now we are just going to clean up the numerator a little bit because it's not going to be too awful, so that I don't have to write the whole problem over again. I'm just going to write right above it. Okay. And some people can do this in their head, but the more you write, you know, the better off you're going to be. So distributing the 3 through here, what's that going to give us? All right, good. 6x minus 3. Now watch me point to this. We want to distribute a 2, but we also want to distribute a negative. So think of it as distributing a negative 2 through both of these. That would give you negative 6x minus 14. And we're just going to put all that together into our answer. Weirdly, what did we end up with in the numerator? Yeah, why is it just negative 17? Yeah, those canceled out. And so that's your final answer. So it was worth it to keep going because we did simplify it down and it made it look a good bit better. This one, as a heads up, is not going to be the case. We're going to write out the problem and then just stop because it's going to be a total disaster. So start all the way over here. Where do we begin with? What's the denominator? Good. So it'll be 5x cubed minus x. That's a cubed. Yeah, I don't know what you were looking at.
It was.
Never mind. Okay. Times derivative of the numerator. So what would the derivative of the numerator be? Yep, 2x minus 3. Oh, you guys are already quick with that. Minus the numerator. So just copy that over. This is a lot of copying, so you have to be careful about copy errors. All right, times derivative of the denominator, which would be 15x squared. Oh, this is a little tricky. Oh, good. Why is it minus 1? There is an x, and the coefficient is 1, and the power is 1. So those ones do mess people up. And then it is over the denominator squared. That we will just leave alone. Can you look at that and use your common sense and be like, okay, that one we're gonna just be done with for right now? Yeah, we'll leave that alone. All right, 14. All right, so where are we gonna start? Denominator, square root of x times derivative of the numerator. What's your derivative of that numerator? It's just 1. Now, eventually, you will probably get to a point where you might not write that. For right now, I would like for you to put it because you are learning the pattern and it's part of the pattern. Okay, so at least for like the first couple of times, can you come with me on that? You may get to a point later in the year where you're like, yeah, I'm not going to write it, but for right now, please do it. All right, minus the numerator times derivative of the denominator. Thank you. Oh my gosh, you guys are awesome. Do you remember how I said it's going to save you a lot of heartache if you just know that one? You don't have to stop what you're doing and worry about all the 1/2 and negative 1/2 and this and that. All right, now this is actually kind of nice as well. It's over just x. Now, I am going to keep going with this one because I have seen on the AP exam, they'll throw square roots in here and then make you simplify it down on multiple choice questions. So we are going to do this. I'm sorry. But I want to have covered it, you know. We're going to multiply by 2 square root of x in the numerator and denominator. Can you look through and think why I would maybe do that? Like, the point is it's going to cancel with that. Okay. That's like the point. All right, so derivative equals, I'm going to distribute through the numerator. All of this is one term, by the way. Like this whole thing all goes together. So if we multiply to the first part, well, there will be a 2, right? And then square root of x times square root of x is just x. Now, when you distribute it to the second part, they cancel. That was the whole point, okay? So then you'd have, well, we can distribute that negative into there, right? Minus x minus 5. And then in the denominator, you would do nothing to this. You're multiplying x times 2 square root of x. I mean, you would maybe put the 2 out front just because it's a coefficient, but we are not rationalizing that. You will leave it alone. And there's actually only one other thing. The numerator would just be 1x minus 5. And again, the reason I made you do that is I've seen ones like that where they make you go the whole distance and simplify it down. And I just want you to do well on the APs. All right.
Wait, why is the 2x still one?
Oh, it was 2x minus 1x. So we just combined like terms. So 2x minus 1x just gives you 1x. They just went together. So it didn't go away. They just combined. All right, this will actually be like a perfect amount of time here before lunch. So these ones have words in them. That's fine. You just have to read the problem and know what it's asking you. Huh? Easy, right? Find the instantaneous rate of change. What does that mean? Derivative. It means derivative. It is fancy directions for find a derivative, d dx. So you're going to find the derivative at 8. And I'm going to grab a calculator and we're going to review how to type this, okay? So I would start by rewriting the function. Notice I'm not going to put a prime. Do you see how I did not do a derivative? Let's just rewrite this. It'll be 2x to the what? That's a cube root of x there. Oh, I would not give you an 8th root. I stick with square roots and cube roots. It's a cube root of x. I'm sorry, it's just tiny. So what's the power for that? 1/3, except it'll be, why will it be negative? It's on the bottom, okay. I stick with square roots and cube roots. That's, well, because those are the ones I see on the AP exam. I don't really see anything much weirder than that. All right, now we're going to do the derivative. So now put a prime. So you're going to multiply the negative 1/3 down. That's going to give you negative 2/3. Put x, and then this is tricky. You have to subtract 1. So negative 1/3 minus 1. And someone's always smart, goes negative 1 1/3. And I'm like, haha, no kidding. It's going to be negative 4/3. And we're going to rewrite that. So draw a fraction bar. I don't know, but for some reason that calms you down. It's like, okay, at least I have the bar. Now I just have to decide what goes where. So negative 2 is going to go on the top. 3 is going to go on the bottom. Oh, good. Cube root of x to the, good, perfect. You guys got it. Great job. Oh my gosh, I love this class. You guys are fantastic. All right, now there's one more step because it says we have to plug in 8. Now I realize that says 8 to the 4th. Can I cover that up really quick? Do the cube root of 8 first, because you know that one. Cube root of 8 is 2. 2 to the 4th. 2 times 2 times 2 times 2. It is 16. So we end up with this. Talking too much. Again, we did cube root of 8, which was 2. 2 to the 4th is 16. And so that's going to be negative 2 over 48. And so final answer would be negative 1 over 24. Let me just real quick, let's review how to type it in the calculator. How do you get a derivative on the calculator? I'm not going to make you all get a calculator, you just need to watch. Math, 8, good. Then what do I type? X, because it's d dx, and then the function. Alpha y equals will give you that fraction bar. 2 over cube root is also in the math menu. If you ever can't find something, try the math menu. That's where everything is. All right. And then such that 8. And then if you want to check negative 1/24, that's what it came out to. Wild. I know. All right. Let's try a couple more. This one says write the equation. Ooh, what 2 things do you need to write an equation? Good. A point and a slope. Write it out blank. That's your scavenger hunt list. We have one part of that. What have we got? Yeah, x is negative. That's your point of tangency. Real quick, I'm not going to make you do this, but if you were going to use your tangent line to approximate things, what are some numbers you could approximate? Negative 1.2 or negative 0.9. You see what I'm saying? Really close to negative 1. All right, how do I get the y value? Plug it in. All right, let's see. 6 times negative 1 would be negative 6. Down here, what would that come out to? 4? 3 plus 1. All right, so that is negative 3/2. Cool, we have the point. Slope comes from, okay, which rule that I just taught you do we need? Good, quotient. Identifying what rule you need is oftentimes the hardest part, all right? So where does it start? Denominator, so 3x squared plus 1. Derivative of the numerator, 6, good, minus 6x, numerator, times derivative of the denominator, which is weirdly also 6x, and then over denominator squared. Now, here's a really common mistake that happens. You know how I talk about copy errors all the time? Another really common one is called a linkage error. This is f prime. When you plug in negative 1, it's now f prime of negative 1. Don't write this on your paper. If you put an equal sign and then start plugging in negative 1, they will not give you the point because one of them is the regular old derivative and the other is the derivative at negative 1. Do you understand the difference? The way around that is to just not put any equal signs. And we're going to talk about that more when we review for the AP exam, but don't write any equal signs ever on anything. Just don't link anything together. Just do all your work and don't link them all together. Or do all your work and go back and erase the equal signs. You're all just staring at me. Is that because we're tired? Do you understand what I'm saying? All right. Don't write an equal sign. All right, so let's just plug in negative 1. This first part would be 4 times 6. If you plug in negative 1 to both of these, you would have negative 6 times negative 6, which would be 36. Over, what is that going to be? 4 squared? So 16. So let's see, what's that? 24 minus 36. That's negative 8? No, negative 12, right? Negative 12 over 16. And then what's that going to reduce to? Negative 3/4. Cool. Okay, we got there. This is your point, this is your slope, just put it all together to write the equation. It'll be y plus 3/2, good, equals negative 3/4 parentheses x plus 1. The hardest part in that problem is honestly the arithmetic and reducing fractions. All right, and then here we're going to talk about what's called higher order derivatives. That means a derivative of a derivative. So this says find the fourth derivative. Nothing to worry about. You're just going to keep taking derivatives. It's actually kind of fun. All right, here's f prime. This is your first derivative. This is just power rule. What would be your first derivative of this?
X squared plus 4x.
Good. 18x squared plus 4x. Constants go away, so that negative 8 is gone. Now, when you go to do a second derivative, there's just a double prime, and you're literally just going to take the derivative of the first derivative. So that would be 36x plus 4. Third derivative would just be 36. Now, when you get above 3, we just put the numeral there. So the fourth derivative would look like that, and a fifth derivative, you would just put a 5. And don't stop listening to me as soon as we're done, because I have one other notational thing to tell you. We're not going to do any more problems, but I need to show you notation for something. What's your derivative of just 36? If you take enough derivatives of a polynomial, it will eventually go to 0. That's not true for things like square root or like rational functions or anything. But if you have a polynomial and you take enough derivatives, you will eventually get 0. Okay. Now, do you remember our notation dy dx for a derivative? Okay. For a second derivative, it looks like this with little 2's in it. The common mistake is people will do a derivative squared. It means second derivative. And then this is your notation for a third derivative.